Hi cuties, hope you're having a good day. In the past few videos, we are discussing about the divisibility rule of various numbers. So today let's continue with the divisibility rule of two more numbers. Divisibility rule of 8. The divisibility rule of 8 says that a number is divisible by 8 if the last three digits are divisible by 8. So let's look into a small example. I have started with an example 4832. So our aim is to check whether we can divide this number perfectly with 8 without leaving a remainder. So in order to confirm that we can divide this number perfectly with 8, we just need to look into the last three digits. 832. So I have written that separately here. 832 divided by 8. Just to confirm that it is divisible by 8. So if you see, let's see how to divide it without doing the actual division. So I am going to take the first number 8. 8 divided by 8. I have written the answer 1. Now I am taking the second number 3. 3 alone. But 3 alone I cannot divide by 8, right? So I just put a 0 because I cannot divide it by 8. Then I took the next two digits together, 32. 32 divided by 8, 4. So 832 divided by 8, the answer is 104. Actually, this method you can easily use to divide also. You don't have to always do the long division method to find the answers. So since 832 is divisible by 8 correctly without leaving a remainder, you can say the entire number 4832 is also divisible by 8. Now let's look into one more example. 65,624. Directly let's go to the last three digits. 624. 624 divided by 8. Let's see how to divide it again without the long division method. We'll start with the very first digit 6. 6 divided by 8. Do you think it's possible to divide 6 with 8? No, not possible. So let's not write 0 since it's the first number and we don't see a number with starting with 0, right? So no need to write a 0, but just take the second digit also together with it, which means 62 divided by 8. So 62 is not perfectly divisible by 8. There is a remainder. If you check the 8's table or the multiplication table of 8, you can see that 8 sevens are 56 and 8 eights are 64. So in between lies the 62. So let's take 8 sevens, which is 56, and let's subtract 56 and 62. So 62 minus 56, you'll get an extra 6 and we are going to add a 6 here. So don't forget to write the 7 first because we are already taking 7 eighths. So let's write 7 first and the remainder 6 is added with this 4 to read it as 64. 64 divided by 8, perfectly divisible 8. So the answer is 78. So don't worry, let's look into this kind of division in detail in another video. But here let me conclude that 624 is perfectly divisible by 8. So this entire number 65,624 will also be perfectly divisible by 8 without leaving a remainder. So I hope the divisibility rule of 8 is clear. Now let's look into one more divisibility rule. Now let's look into the divisibility rule of 12. A number is divisible by 12 if it is divisible both by 3 and 4. Do you remember hearing a similar divisibility rule anywhere? Actually, the divisibility rule of 6 was something similar. A number was divisible with 6 only if it is divisible by both 2 and 3. Same way, a number can be divided by 12 without leaving a remainder. Only the same number can be divided perfectly with 3 and 4. Or in simple words, 12 will become friends with a number only if the number is friends with 3 and 4. Let's look into an example. 1236. So here, it's a good chance to revise the divisibility rule of 3 and 4 also. The divisibility rule of 3 was add the digits. If the sum of the digits is a multiple of 3, then yes. So let's look the sum of the digits. 1 plus 2 plus 3 plus 6. The sum is 12. 12 is perfectly divisible by 3 and the answer will be 4. So yes, it's divisible by 3. Now the same number, let's look the divisibility rule of 4. The divisibility rule of 4 says if the last two digits is divisible by 4, then the number can be divided by 4. So here the last two digits is 36, and 36 divided by 4 is 9, which is perfectly divisible. So divisibility rule of 4 also successfully satisfied, which means this number 1236 can be perfectly divided by 12 without leaving a remainder. Now let's look into an example which is not going to be divisible by 12. 567. First let's check the divisibility rule of 3. 5 plus 6 plus 7. The sum is 18, and 18 is a perfect multiple of 3, so divisibility rule of 3 is satisfied. But let's look at the last two digits. 67. 67 divided by 4. No, there is actually a remainder. So you can say it's not a perfect divisible number with 4. The divisibility rule of 4 is not satisfied. So the number 567 cannot be divided perfectly with 12. So this is the simple rule to check whether a number is divisible by 12 or not. Now we have two more numbers left to check the divisibility with. So let's see that video in the next video. So thank you. If you are liking my videos, please like, share with your friends and subscribe.